In the world of software development, building robust applications requires not only writing code that works but also ensuring that the application can handle unexpected situations gracefully. This lesson focuses on best practices for error handling in C#, which is crucial for developing reliable applications. By the end of this lesson, you will understand how to effectively manage exceptions and create user-friendly error messages. Don't worry if this feels new at first. Now we're on understanding exceptions. In C#, an exception is an event that occurs during the execution of a program that disrupts the normal flow of instructions. Exceptions can be caused by various factors, including invalid user input, unavailable resources, or programming errors. When an exception occurs, it can lead to application crashes if not handled properly. Using try-catch blocks, let's dig in. One of the primary ways to handle exceptions in C# is by using try and catch blocks. The try block contains the code that may throw an exception, while the catch block contains code that executes in response to the exception. I'll let you read the examples on screen rather than reading every line aloud. In this example, accessing an index that's out of range raises an index out of range exception. The catch block captures the exception and prints a user-friendly message. Now we're on multiple catch blocks. In some cases, you may want to handle different types of exceptions differently. C# allows you to use multiple catch blocks to handle various exception types. You'll use this often as you go. I'll let you read the examples on screen rather than reading every line aloud. In this code, if the user enters a value that can't be parsed as an integer, a format exception will be caught. If the number is too large or too small, an overflow exception will be caught. The final catch block captures any other type of exception. Next, finally block. Sometimes you may need to execute code regardless of whether an exception occurred or not. The finally block is used for this purpose. It runs after the try and catch blocks, ensuring that cleanup code is always executed. See the example on this slide. Pause if you want to study the details. In this example, the finally block executes whether or not an exception was thrown, providing a message indicating that the execution is complete. Creating custom exceptions, let's dig in. For more complex applications, you may want to create your own exception types. This can provide more context for the errors that occur in your application. To create a custom exception, you can inherit from the exception class. This slide introduces a class definition. Study the structure in the code sample. Now, you can throw this custom exception in your code. See the example on this slide. Pause if you want to study the details. This allows you to throw and catch specific exceptions that are meaningful to your application. In this lesson, we covered the fundamentals of error handling in C#. We learned about exceptions, how to use try and catch blocks, the use of multiple catch blocks, the finally block, and how to create custom exceptions. Mastering these concepts will enable you to build more robust and user-friendly applications. Go ahead and work through this exercise. First, implement a try-catch block around a division operation to handle division by 0. Also, create a method that throws a custom exception when a negative number is passed. Also, use multiple catch blocks to handle both format exception and overflow exception when parsing user input. Finally, write a program that reads a file and handles any file-related exceptions gracefully.